So today, again, we're going to be going over systems of equations. And we talked earlier that systems of equations is when you have two or more equations but that meet at a point, right? And if you know where that point is, the y or the x value of the point, you can figure out what the solution to that equation, those systems of equations are. Okay. So what we're effectively doing here is we have three lines, and each one of those has an equation. We have line, we'll call this one line red. Okay, we'll call it, or you can call that line 1 if you want to. Okay, we have line blue, call that line 2, and then we have this third one, call it line purple, and this is line 3. It's this one right here. Okay, and they all meet at this point. Okay, but are these, what form are these equations in? Standard form. They're in standard form. Ax plus by equals c, right? But in that standard forms aren't real useful for me. So what I can do is, what I need to do is rearrange these equations so that they're useful for me. Okay, so for this first one, I need to put it in what form is the most useful for me, you think? Slope intercept. Very good. All right, so we have slope intercept form. So we have 2x plus y equals 2. Easiest way to get there is y equals something. So we're going to move that 2 to the other side and make it negative 2x. Right? So y equals negative 2x plus 2. Okay? Let's go ahead and recopy that down into the bottom left-hand block for your red equation. Y equals negative 2x plus 2.
Where are you writing?
Right here. Right there. Okay? So what can I identify from this equation? Which line is it? Can I tell which line this is going to be that it shows?
Yes.
What do you think? What number is going to be useful from that?
The y-intercept?
Okay, yeah, and what is the y-intercept?
2.
2. Very good. Right, so here is our y-intercept. And the only line that crosses the y-axis at 2 is this one right here. And also notice it's the only one with a negative slope. Okay, so the slope is negative. Right, so this is the first line, line 1. Okay, and I'm going to highlight it as red for the sake of my notes. Okay, so this is line red. Like that. Okay, so now we'll move on to line blue. Line blue, it's not in y equals mx plus b form, but it's in x minus y equals negative 5. Easiest way to move this one around is to take that one, negative y, and put it on that side.
I can't see.
Take the, is that better?
Mm-hmm.
Okay. Take the y, or the 5, it's negative 5, put it on that side, it becomes positive. So when I do that, I get x plus 5 equals y equals x plus 5. Y equals mx plus b. Okay? So, knowing that, how can I identify any useful information from this line? What do you think? What do I know about this line because of this?
Because of what?
Because of this equation. What do I know about from the blue line?
It's positive.
It's got a positive slope. Where does it intersect the y-axis at? The y-intercept. Yep. So right here is our y-intercept. So it's got to be this blue line right here. All right. So I'm gonna. There's line blue, just like that. Okay. And then I transpose that down into the middle block at the bottom. Okay. And so leaving the last one is going to be 5x minus 2y equals negative 13. Let's get the y positive and move the constant to the other side, kind of like this, right? So we're going to get 5x plus 13 equals 2y, right? So it's 2y, we're solving for 1y. We need to do what? What do we need to do? For solving for 1y, we have 2y. What do we got to do?
Keeps telling me
divide by the coefficient of the variable term, which is 2. Variable term is y, so we're going to divide each side by 2, divide that by 2, divide that by 2, okay? So we're going to be given, therefore, this is a therefore symbol, okay? Therefore, y equals 5/2 x, because 5 divided by 2 is 5/2 with an x attached to it, plus 13/2, which is 6.5. Because think about it, 12 is 6 times 2. An extra half is going to be 13 times 2. Okay? So that is our equation, our purple equation. Y equals 5/2 x plus 6.5. And you can see here that this line, if it did go off scale, would intercept it at about 6.5. And it's got a pretty steep slope of 5/2. So this is going to be our purple equation. This is our purple equation. Okay, so this is equation 3, and this is equation 2, if you're using the net to markup stuff with. Okay, so what is the solution of this? How could I tell what the solution for these 3 lines are going to be? Well, the solution is going to be where those 3 lines meet. Okay, the point at which those 3 lines meet. So the solution of any system equation is the point of intersection. So what is the y value for, or the x value for this, and what's the y value for this? What's the x value for this black point here? It's -1, and what's the y value? 4. So that's our solution. So it's -1 and 4, both of these. I need this one and this one. Okay, so that's how I do it, just looking at a graph. But how do I prove it? How do I prove it algebraically? Well, I know that at this point, all my y's are the same. They're all 4. Okay? But, I mean, that's how these things are going to work, right? So y equals y, which equals this y. All those y's are equal to the same, and those y's equal that, and they equal this.
Can you see the examples?
Okay, so for substitution, you can just substitute these y's here for their terms of x expressions, right? So this, if y equals y, then this expression equals that expression at the point that they intersect. Okay, so -2x plus 2 equals x plus 5. X plus 5. All right, so now how many terms? Up here I had 2 terms. I had y and I had x. I had y and I had x. Making the substitution, saying that y's equal this, now how many terms do I have? I have 1 term, right? And that term is x. Now I have to solve for x. Okay, so solving for x, I'm going to take this x, I'm going to move it over here. It's going to make it minus x. Okay, so it's going to be -2x minus x minus x, and it's going to be equal to this 5. This 2 is going to move over to this side, making it -2. So it's 5 minus 2. It's equal to 3. Okay? So here we have -2x minus another x makes us a -3x equals 3. Divide both sides by the coefficient of the variable term, that is by -3, and then I will therefore have x equals -1, because negative divided by positive is negative, and then a 3 divided by 3 is 1. Okay, and you can see that that is the solution point for my solution set, my x value. Okay, now that I have that, x equals 1, I can plop it into either one of these equations to figure out my y value. Okay, I'm going to pick the easier one, x plus 5. Okay, so I'm going to take that y equals, I'm going to bring this -1 up here. Okay, it's going to be -1 plus 5. Y equals -1 plus 5 equals 4. And you can see right there, our solution set is 1 and 4. Okay? So there's our solution set. negative 1 and 4. Excuse me, negative 1 and 4. Hey, but I can do the same thing here. The blue y equals the purple y, which equals that and that respectively. Okay, so we'll just set x plus 5 equals 5/2 x plus 6.5. Again, I just substituted the x's for the y's and for the expressions for what y equals. So I just swapped. I just set that equal to that. That's all I did right here. Okay, so solving for x. Let's get rid of fractions. Okay, so how do I get rid of fractions?
Multiply by the biggest denominator.
Yeah, multiply by the biggest denominator. Okay, you might have to do that multiple times, but this time you don't. Okay, so I'm going to multiply this term by 2. Its biggest denominator is 2. Multiply this term by 2, that term by 2, and that term by 2. When I do that, I get 2x plus 10. The whole reason I picked 2 is so that this 2 would go away, leaving me 5x plus 13. Okay? So then I'm going to take this 5, move it to this side. All right, it's going to be negative 5 plus 2. What's negative 5 plus 2? Negative 3. It's going to be negative 3x. Right, and then we have equals a 13 minus a 10. I make it over there and become minus. Okay, so 13 minus 10 equals 3. Again, we have the negative 3x divided by 3, so equals negative 3x equals 3, so we have x equals negative 1, right? So we prove that that equals negative 1, and if you wanted to figure out what this would equal y at, you just plop it back into that one, and the math's the same. It's 1, 4. Okay. Any questions on this? Questions? Any questions? Okay, pretty straightforward. All right, look at the page. All right, here's a different approach. It has 2 equations. We need to plot them and prove that where they cross, right? Figure out where they cross. Okay. So are these equations in the form we want? Are these equations in the form we want?
The what?
The form that we want. It's in point slope form, or is it? It's in slope intercept form. Excuse me, slope intercept form. Well, that's what I want. Right? I want them in slope intercept form. That way I can easily identify the key points from that line of the equation. Okay, so we'll call one of these blue, one of these red. Top one will be red, bottom one will be blue. Okay, and how do I figure out where these 2 lines cross? What is the x-intercept that these 2 lines cross at? Or sorry, what are the x value where these 2 lines cross? How do I figure that out? We just did it. We set this value and that value equal to each other. Okay? So 0.6x plus 5 is going to be equal to 0.3x plus 14. Okay? I got rid of my y terms. All I have is x terms. I did that by substitution. Okay? So now all I have to do is solve for x. So I move this to this side, making it negative 0.3x. So what's 0.6 minus 0.03? 0.3x? What's 0.6 minus 0.3?
0.3.
So I have a 0.3 x equals, and then I'm going to move this 5 over to this side, makes it negative 5. Okay, so what is 14 minus 5? It's 9. All right. So now I got to divide both sides by the coefficient of the variable term. Coefficient of the variable term is 0.3. Divide by 0.3, 0.3. And if I go 9 divided by, so this gets rid of the 0.3, it gives me x equals 9 divided by 0.3 is equal to 30. So these 2 lines are going to cross at x equals 30, somewhere up here. We don't know the y value yet. Okay, we have to take this value and plug it back into one of these 2 equations. Which one do you want to use, red or blue?
Red.
Let's use red. Okay, so we're going to say our y equals 0.6 times this times 30 Okay, plus 5. Okay, so that times 0.6 equals 18. Y equals 18 plus 5. 18 plus 5 equals 23. All right, so these are going to cross at right here. So at the point, at the intersection of 30, 23 is where these two lines are going to intersect right here. Okay? So I got 1 point on both the lines. All right? How do I identify where the red line crosses the y-axis? Where's the red line cross the y-axis? Where's the red line cross the y-axis? This red line, this red line equation. Where does that cross the y-axis? Positive 5. This crosses at positive 5. And what is the slope? This is 6 over 10. 0.6 is 6/10, right? Which can be reduced to 3/5. Right? So it's going to go up 3, 1, 2, 3, and over 5. 1, 2, 5 right here. Okay? So my red line is going to intersect these 3 points. And it's going to intersect them. If I did everything right and plotted everything right, it intersects them just like this. Nice straight line. That's y equals 0.6x plus 5. Okay? Now my blue line, I do the same thing. What is the y-intercept for my blue line? Y-intercept for my blue line. 14. Yep. So it's going to intercept here at 14. And my slope is 3/10 because that's 0.3. 3 over 10. Can't reduce that, so it's going to go up 3, 2, 3 to 17, and over all the way over to 10. Right? So those are 2 points, and if I did everything right, those 3 points should all lie on this line right here. Oops, did I make a mistake somewhere? Okay, so this goes up 3, 1, 2, I did, and then right here, there's my mistake. Point was plotted a little wrong. Okay, so now it should line up better.
That's up 2.
Yep, I went up 2, so this is up 3. Let's make my dot bigger. Okay, good call. Okay, so this is my line 0.3x plus 14. Right, and you can see that they intersect at, this is my solution. My solution set is 30 and 23. I just verified it with those lines. Okay, any questions on that stuff? We're going to forego that last question for the sake of time. Questions? Okay.